Going through the answers of the calculator group test. So taking a look at question number 1, kind of got a review question, maybe a little bit of a step up from pre-calc with this input here. So we're still trying to figure out, first of all, setting up that relationship for the triangle for arctan. So the answer of arctan is an angle, so I'm going to put a reference angle in my triangle here. Tangent is opposite over adjacent, so I set up that a over 4. And then I didn't show my work, but I used Pythagorean theorem to solve for that missing side. A squared plus b squared equals c squared, and then square root. So now we're looking for cosecant of that angle. Cosecant is the reciprocal of sine. Since sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite, which is what I have set up here. But again, since I didn't initially think I was recording videos, I wanted to be really clear with my work where that answer was coming from. So this is a more complicated way to find it, actually. The easier way would just be thinking of flipping that sign as you go. Question 2, finding the derivative of an arcsine function, so using that pattern. First of all, multiplying by 10, that goes along. 1 minus everything you're taking that arcsine of squared. I am not going to expect you to simplify that, so just leave that alone. And then times the derivative of what's inside, which would be derivative of 9x squared gives us that 18x. Derivative of 21x gives us 21, and derivative of -7 is 0, so that goes away. So I did go ahead and distribute my 10 through the numerator. If you chose to leave that in factored form, that's fine as well. Number 3, this one says evaluate and show all work. So I know it's on a calculator part of the test, although I will say I did switch that up for the test itself, so there won't be any definite integrals on the calculator part of the test. So you will be showing your work for those by hand without a calculator. First of all, recognizing the pattern. Now, some of you might be able to do this without U substitution. I think it's a little trickier once they start throwing those trig functions in there. But a is the square root of 36, which would be 6. And then the u would be the square root of cosine squared, which would be cosine. And we do have, for the most part, that derivative in the numerator, except for the negative sign. Again, if you let u equal cosine of x and kind of explicitly put that into your integral, it might be a lot easier for you to see. But I just wanted to clarify this is doable by recognizing the patterns. All right, so I did change my bounds since I used U substitution. If you didn't, then you would have the same bounds, but I'm showing subbing in that 0 to my U for the lower bound, and then subbing in that pi over 3 for cosine to get my new upper bound. And then this is our arcsine pattern. So we have the arcsine of U over 6 with our new bounds. And then I'm just showing my work for subbing in. We end up with arcsine of 1/12 minus arcsine of 1/6, which then I used a calculator just to get an approximate value for my final answer. Example 4, same thing. This is doable by recognizing patterns, but again, with that trig thrown in there, you might want to go ahead and let u equal tangent. Derivative of that is secant squared, which replaces our numerator. And then we have in the denominator, I was kind of explicitly showing that square root of 8 squared gives us that a value. And then the u squared, of course, u is our u value. Integrating, this is our arctan pattern. So it's 1 over a times the arctangent of u over a. And then, of course, plus c. This is not a definite integral. It's a general integration. And then I rationalized and subbed back in for u with that tangent of x. I did also simplify my square root of 8. I'll be honest, you guys, at this point with the distance learning, if you got to this step right here with the 1 over square root of 8, and then you just subbed the tangent of x back in and left it unrationalized and unsimplified, I'm going to accept that. My focus here is for you recognizing these integral patterns versus kind of some of the pre-calc algebra stuff. But if you wanted to simplify, you could. So there's the answer in simplest form, but you could leave it unsimplified as well. Example 5. This one is asking for, if you look at the very last sentence, find the rate of change. So as we all know, rate of change means derivative. So we're finding the derivative of this function given a present value for the oil change of $29.95. So I subbed that in for P. And then because we were also looking for the derivative at a specific point, and this is on your calculator part of your test, I did just go ahead and use my calculator for this. You guys remember that Math 8 gives you that numeric derivative. So right here, this is the notation that your calculator would show. So I showed my calculator notation, and then it told me that the derivative at 6 is approximately 1.6967. Example 6. So first of all, right here, it says this grain is spoiling at a rate. So we're given the rate, and we are being asked for the weight. So that tells us we need an integral. So we start by separating those variables, multiplying both sides by dt, and then I let u equal my denominator. Because when you take the derivative of the denominator, the t goes away, and so we can compensate for that extra coefficient in the numerator. So took the derivative of that denominator and then multiplied both sides by -2 to get that dt alone. So what I did was, first of all, when I integrated dw, I just used function notation. So if you just had w, that's fine, but I used that w of t. And then I pulled the 32 out front from that numerator, that's just a coefficient. And then from my derivative, that -2, that's a coefficient as well, so that went outside, leaving me with just 1 over u du to integrate, which gives us that natural log of u, and then I multiplied my two numbers together. All right, so to solve for c, we have to use this initial condition, t equals 0, and the weight is 2,000 pounds. So I subbed 2,000 in for my w, I subbed 0 in for my time, and then I was able to solve for my c value. Writing that function, which it did ask for, so it asked for the equation that gives the weight at any time t, so that's my equation, and then I didn't show any work, I just used my calculator, subbed 7 in for t, and got about 2,022 pounds for the weight. Example 7, this one was literally just a calculator question, so it's setting it up exactly for you. I just typed it in just as it looks on my calculator, and it gave me about 11.375 minutes. And finally, question 8, same thing. It's asking for a rate of change given an x value. So it's asking for a numeric derivative. So that is just using our calculator. That's that Math 8 button for the numeric derivative. And I got approximately -0.126.